In this slideshow, we will continue examining the oxidation-reduction reaction. The combustion reactions, as I explained, when the organic compounds react with oxygens and produce carbon dioxide and water, combustion reaction is in fact, it is oxidation-reduction reaction. So this is an example of butane react with oxygens and producing carbon dioxide and water. And this is in fact redox reactions. Let's move to the next slide. However, to understand combustion as a redox reactions, we cannot look at the movement of the electrons like we did with previous examples. The example you see here, when zinc react with copper sulfate, you could assign the charges for zinc, which is 0, and right hand side you could assign zinc is +2 because it is zinc cations. And you can find how electrons are moved around. However, when you look at combustion reactions, every single substance in this combustion reaction is molecules. They are all molecules. Therefore, you cannot assign the charges like did before. Because there's no ions in all of this compound you see in the butanes, oxygens, carbon dioxide, and water. They are not made of ions, so you cannot assign the charges to find out which one is reduced and which one is oxidized. So in the situation like this, we need to use another rules. Let's move to next slide. So the new rule you're going to use here is a little bit different. You could say atom is oxidized if it gains oxygens and or loses hydrogens. The opposite, the atom is reduced if it loses oxygens and or gains hydrogen. So let's look at this using the example. Let's see how this works. In this reaction, butane is originally C4H10. On the right hand side, let's look at what happened to C4H10, what happened to the carbons. Carbons is now combined on the right hand side with oxygen, CO2. So C4H10 becomes CO2. So what happens? Well, the carbon atom in butane gains oxygen atoms and became carbon dioxide. And of course, at the same time, hydrogen is lost. Therefore, according to the definitions, yes, butane is oxidized, and that means, remember, butane is a reducing agent. And also, it is also convenient to remember, oxidation reduction always happen together. And so, if something is oxidized, the other one must be reduced. Or something reduced, the other one must be oxidized. So when you look at this here, what happened to the oxygens? Well, of course, you could say oxygen is reduced, and oxygen is oxidizing agent. And of course, oxygen is oxidizing agent because oxidizing, the word itself, oxidizing, come from oxygens. So the oxygen is oxidizing agent. Let's move to the next slide. So in these equations, it looks very complicated, chemical reactions, but you could still find the answer. What is oxidized and what is reduced, or what is oxidizing agent and what is a reducing agent? How do you find this out? Let's move to the next slide. In this case, let's use the two rules together. So hydroquinones became benzoquinones in the right-hand side. So when you look at these two formulas, hydroquinone and benzoquinones, you should notice the change. The change is hydroquinone lost hydrogens. What does this mean, lose hydrogens? It means it is oxidized. So that means hydroquinone is reducing agent. Let's look at the silver. Silver cations became silver atoms in the right-hand side. So what happened to the silver cations to silver? Well, silver cations gain the electrons, so that means it is reduced and it is an oxidizing agent. Let's move to the next slide. So this is a typical situation you will see when you study biochemistry, for example, is you see the transformation of two compounds. So question is, this transformation is a compound oxidized or reduced, and how do you find this out? When you look at the formulas, left and right hand side, what was a change? Oh, by the way, these reactions is not necessarily balanced. Number of the elements on the left hand side and right hand side is not the same, and that's okay. In this case, what you are focusing on is what happened to the chemical compound. So just focus on the transformation instead of looking at the numbers of elements. So simply looking at the transformation, you see that left hand side compound lost hydrogens. It lost hydrogens. Therefore, this transformation is oxidization. In other words, it is oxidized. And that's how you can answer these questions. This is the end of the slideshow.